Alright guys, so I wanted to take a little bit of time to talk with you about arithmetic series. Alright, so we already know what an arithmetic sequence is. It's a sequence that has a common or constant difference, that as you progress from one step to the next, it always has the same difference. So now let's look at how that is associated with the series. Now, just like with the sequence, we were able to come up with a general equation that helped us solve for the general term, we can now create something very similar for an arithmetic series, which is essentially the summation of an arithmetic sequence. All right, so let's first consider Sn. Okay, so Sn in general means that I'm going to take, so let me just write this out, Sn equals the first term plus the second term, but instead of u2, because this should be the second term, u2, according to the definition of an arithmetic sequence, is just u1 plus d, right? Because I'm going to add whatever the difference was from the first to the second term. And then plus, now this should be u3. But u3 is just u2 plus another d, or u1 plus d plus d. So u1 plus 2d, right? Now, you've seen this before, actually. I have no idea what just happened. You've seen this before because we did this when we were building the idea of an arithmetic sequence. We saw the u1 plus the difference, the u1 plus 2 of the difference, and we keep going with that. And so from this point, I'm just going to say la-di-da-di-da, fourth term, fifth term, blah, blah, blah term, all the way up to, now the last term, of course, is going to be un. Now before un is going to be un minus d, right? Because that's how you get to the previous term. You subtract d once. And then the one before that is going to be un minus 2d's, right? So I subtract d once, I subtract d twice. So now I'm going backwards with the terms. So that's the general equation for Sn. Does that make sense so far? You can't answer me, can you? So now what I'm going to do, strangely, is I'm going to write it backwards. For no other reason than it's going to be interesting when we put everything together. So just follow along with me for a minute. So instead of writing it this way, I'm going to start with the un, and then I'm going to add the un minus d, and then I'm going to add the un minus 2d, and la-di-da-di-da. You won't ever have to do this. I'm just going to show you something that looks really cool. So I've got the un plus 2d, the un plus d, and the, sorry, those should all be u1s. Sorry, that should be a u1 right there. So u1 plus d. All right, so essentially I've just written this whole thing backwards with all whatever the missing terms are, all of those missing terms in the middle. Now, hopefully you can see at this point that if I add these together, something very interesting happens. All right, so I now have 2Sn, okay, equals, now right here I've got u1 plus un. Now what happens if I add these two together? The d's are going to cancel out, leaving me with u1 plus un. Interesting. And look, the negative 2d and the positive 2d are going to cancel out, again leaving me with u1 plus un. And it's going to go on and on and on. And when you get to the other end, you'll notice again, they cancel out. I'm left with u1 plus un. And it happens again, over and over and over, as many terms as there are. This is going to happen. And again at the very end. So essentially what I have here is that 2Sn is equal to 1, 2, 3, 4, 5, 6, all the way up to n number of u1 plus un. So I can write that as u1 plus un, and then there's n of them, right? So if there were 6, it would be 6 times u1 plus un. And to finish it off, just divide by 2. Now this is really nice, and I'm going to write it specifically in this way. I'm going to go n over 2 times u1 plus un. And that right there is one of the formulas to be able to solve for the total of a series, to find the nth term of a series. All right? Now, that is interesting. But we learned something a little bit about UN in our last little unit. So UN, as we know, is equal to U1 plus n minus 1 times d. And if I take this and I substitute for UN, I now have that Sn equals n over 2 times U1 plus U1 plus n minus 1 times d. So I just took the UN and I replaced it with this. And so now we've got Sn equals n over 2 times 2U1 plus n minus 1d. So this is a whole lot of proving, a whole lot of theoretical stuff, but I wanted you to see that these two equations are not magical. Okay? They're not just random things that somebody came up with. This is actually something that mathematically makes sense. It works. You can prove it through a certain process. And so we now have two equations. I'm going to clean this one up just a little bit as I'm talking. We now have two equations that allow us to deal with a series, to find the nth term of a series. In class, we learned how to get the second or the fifth term of a series, but we don't want to have to do all that addition if there's 100 terms. Now we can do it. We can just plug in the 100th term, knowing the first term and the common difference. Or, if you don't know the common difference, you can just use the last term if you know what it is. All right, so at this point, let's go ahead and say, all right, that's enough. Interesting. Let's go ahead and use it. All right, so here we go. Let's find the sum of 4 plus 7 plus 10 all the way up to the 50th term. All right, well, we know a couple of things right off the bat. U1 is 4. We know how many terms we're looking for. We want to add up 50 terms. Now, imagine this, instead of being a sum for a minute, as being a sequence. 4, 7, 10, 13. Can you see the common difference? It should be d equals 3. 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. So our common difference is 3. So we have the first term, we have n, the number of terms, and we have the constant difference. So we can use one of our equations that will now allow us to do that. Here we go, this one right here. It's still showing. It's right there. And so that's what we're going to use. We're just going to say, okay, if I want the sum of the first 50 terms, it's going to be equal to 50 over 2 times 2 times u1, which is the 4, that was the first term, plus n, which was 50, minus 1 times d, which is 3. And so now we can pull out our handy-dandy calculator, and we're just going to type in 50 over, 50 over 2 times, now 2 times 4 is 8, and then plus, and then 50 minus 1 is 49 times 3, and I push enter. It gives me 3875. That is the sum of the first 50 terms of this sequence. Pretty cool, isn't it? Yeah, that's cool. I like that one. Okay, let's do one more, because that was just that was easy, right? That was too easy. We just plugged in the numbers. So let's try another one. Let's find the sum of negative 6, 1, 8, 15, 141. So this time, I've got u1, which is negative 6. I've got the last term. They were very nice. They gave me the last term this night. I have no idea what number term that is, but it is the last term because I'm going all the way up to 141. So, and then I know the difference, right? We can figure out the difference fairly easily because 1 minus negative 6 is 7. 8 minus 1 is 7, 15 minus 8 is 7, so the difference seems to be constant. All right, now at this point, we've got those three pieces of information. We have two equations. The first equation that we had was Sn equals n over 2 times u1 plus un. The other equation was Sn equals n over 2 times 2u1 plus n minus 1 times d. Now the problem is both of these we're going to require n. What number of term is this? And so we're actually going to have to solve for that before we can do anything else. So how do we solve for n? Well, you just use your arithmetic sequence. So let's check un equals u1 plus n minus 1 d. Okay. The last term, we want to know what number term this is so that we know how many terms we're adding up. So let's put in 141 for un. the first term was negative 6 plus n minus 1. N's the thing I'm looking for. What number term is this 141? And then times t, which I know. And so from there, you can solve for n. We're going to add the 6, so that'll be 147. So I've got 147 now equals n minus 1 times 7. We'll divide by 7. And then we will add 1. And so we get n equals 22, which is nice because now that I know that n is 22, I can use either of these equations to find the sum. So I'll just go sum of the first 22 terms equals 22 over 2 times the first term plus the last term. And so easy peasy, 22 divided by 2 times, and then negative 6 plus 141 is 135 and equals 1485. So the first terms are 1485. The first 22 terms added up together, negative 6 all the way to 141, would give us 1485. Pretty cool. Yep, that's pretty cake. That's easy. Now, I'm going to do one more because I got a couple more minutes. So I'm going to do one more. So let's have some real fun. 3 consecutive terms of an arithmetic sequence have a sum of 9 and a product of negative 48. Let's find the terms. This is going to be interesting. We don't know anything other than the sum of the 3 terms and the product of the 3 terms. So I'm going to need some variables. But we don't want to introduce any more variables than we need to introduce. All right? So let's go with this. Let's say the first term is x. Okay? The second term is going to be x plus d, right? And then the third term is going to be x plus d plus another d, so x plus 2d. Does that make sense? Because each term of an arithmetic sequence, you add the constant difference. And so by understanding what an arithmetic sequence is, it kind of gives us a base to start with. The nice thing about this is I only have 2 variables. I've got an x and I've got a d. I don't have a separate variable for each term. All right, so now this is going to be easy because I'm just going to go x plus d plus x plus 2d should equal 9. And then I'm going to go x times x plus d times x plus 2d, and those should all multiply together to give me negative 48. All right, so from this point, you should be able to solve those. I'm going to pause it for a second because you don't need to sit around and watch me do all the algebra. So I'm going to pause it. You work it out. See if you get the same thing that I do, and then I'll give you the answer. All right, so here's my work. I worked it out. I multiplied it out. I took the x equals 3 minus d. I substituted in for x. Then I plotted it here. The x here is resembling the d here because 3 minus d replaced each of those x's. So I typed it out. 3 minus x to the third plus 3x times 3 minus x squared. And then plus 2 times d squared x, and then plus 48 because I moved the 48 over the other side. I graphed it, which gave me a really nice graph, and then I calculated the zeros, which actually gave me a 0 of negative 5 and 5. That meant d was 5 and negative 5. So 3 minus 5 is negative 2. Negative 5 minus, 3 minus negative 5 was 8. So that was my first term, negative 2 or 8, which meant that the sequence could be negative 2 plus 5, or it could be 8 minus 5 minus 5. Either of those two would work, and they both are the consecutive terms. Now that was a pretty tough question. You won't be expected to do something like that quite yet, but the other ones should be fairly straightforward and simple to do, and we're going to work up to these. All right, so there you go. Ciao.